Okay, math helps for Mathematics 610, equations and functions. Problem number 1, translate the following statement into a mathematical equation. A number divided by 5, so this is a complete statement here. They didn't divide it with any commas or anything. Plus 8, that's another complete statement, is 10. A number is identified by a variable or a letter. That's what a variable means. It means we use a letter. Divided by is usually with like the fraction bar. 5 plus 8 is, you use the equal sign for is, 10. Okay, so for this phrase right here, we have this. For this phrase we have this, and for this phrase we have this. So it would be this one right here. Problem number 2, what is the solution to the equation a number divided by 2 minus 4 equals 8? Okay, so we can take each of these numbers here and divide them by 2. 8 divided by 2 is 4. 4 take away 4 is 0. It's not that one. 16 divided by 2 is 8. 8 take away 4 is 4. It's not that one. 24 divided by 2 is 12. 12 take away 4 is 8. Okay, so it would have to be this one. You're just trying to find, it's like a secret code, and you're trying to crack the code, and you have to go through and see what is X being used for. Is it being used for a 1, a 24, a 16, or an 8? And we cracked the code and we figured out 24 is what X was keeping in place there. Alright, problem number 3. Which statement is the clearest translation of this mathematical equation right here? 6, that would be the first part of the problem, plus 4 times a number, that would be the second part of the equation, is 18. Is means equals. So this one is looking like it's going to be the right one right here. This one says 6 plus 4, and then they put a comma, times a number is 18. That would look like this. 6 plus 4 times a number. 6 plus 4 times a number is 18. They didn't split that up very good. 6 plus 4 times a number is 18, and it won't be this one because they didn't put any commas in this one. So this is our best and clearest translation of this equation. Problem number 4, which equation would x equals 10 be a solution? Okay, we're cracking a code again. So is 10 going to work? Which of these equations will 10 crack the code? 6 times 10 is 60, plus 5 is 65. Not this one. 3 times 10 is 30, minus 4 is 26. Not this one. 5 times 10 is 50. 50 minus 8 is 42. There it is. And this one would have been 5 plus 60 is 65. Not that one. So 10 cracks the code for this equation right here. Problem number 5. What should be done to solve the following equation? The equation says d minus 5 equals 3. Well, your unit says that to solve a problem, you must do the opposite operation to both sides. The opposite operation, that is what is being done to the variable. 5 is being subtracted from the variable. So we have to do the opposite of that operation. We have to add 5 to both sides. Okay? 5 minus 5, or negative 5 plus 5, either way is the same thing, is 0. 3 plus 5 is 8. So your problem would say d equals 8. 8 minus 5 is 3. Yes, 8 minus 5 is 3. So to solve this equation, you must do the opposite of subtract, add, and you must do it to both sides. Problem number 6. So problem number 6, we're going to use what we did up here. to solve, we're going to do the opposite operation to both sides. Okay, we have to solve for x. So what is being done to x? Adding. So we're going to do the opposite of adding. And we're going to subtract the 2.3, not the 5.8, 2.3. We're not adding 5.8 to the x, we're adding 2.3. So that's why we have to subtract 2.3. Okay, 2.3 minus 2.3 is 0. And then 5.8 minus 2.3 is 3.5. So x equals 3.5. Problem number 7. 9 less than what number is 17? I'm not exactly sure why they didn't use the commas. But when you see the word less than, that means you're going to be putting this number that's actually in front behind this number that's actually looks behind. So we're going to take what number, that means a variable or letter, okay? What number less 9, so it means this number is being subtracted by 9, is 17, like that. What number minus 9 is 17? If you can't think of it off the top of your head, you'll have to do that thing we've been doing where we do the opposite operation to both sides. Instead of subtract, we're going to add. We're going to add 9. 9 minus 9 is 0. 17 plus 9. I said minus because there's a minus up here, but negative 9 plus 9 is still 0. Okay, 17 plus 9 is 26. X equals 26. Okay, so 9 less than 26 is 17. Problem number 8. What is the solution to this equation? 2.5 minus 8 minus the variable p equals 1 3/4. Okay. This one's tricky because they made the variable negative, and it's kind of hard when they do that. So what we do is we change the signs of everything so that our variable will be positive. That's how I used to do it. You put parentheses around everything and you put minus 1. So we're going to multiply everything by a negative 1, which change it to negative 2.5 instead of positive 2.5, plus p instead of minus, and then this also becomes negative 1 3/4. See how that worked? Okay, now that we've changed our variable to positive, we can do what we've been doing to solve. We do the opposite operation of this to both sides. Essentially what we're wanting to do is eliminate everything by the variable, and so the variable is isolated, it's alone, and then the answer will be over here. So we're going to do plus instead of add. 2.5 and 2.5. 2.5 minus 2.5. See, I'm just reading it backwards. 2.5 minus 2.5 is 0. Okay, and then 2.5 minus 1 3/4. I'm reading it backwards here also because this is the smaller number. This is the larger number, so I want to read it first. Let's work it out like this. 2.5 minus 1 3/4. Okay, remember when adding and subtracting, denominators must be the same. So we're going to change this to the denominator of 4, because that's the common denominator for 2 and 4. All right. And then the whole numbers are the same. Okay. Since the denominator here is the same, then our numerator will also be the same. To find the missing number here, we just go 4 divided by 2 is 2. 2 times 1 is 2. So now we have 2 2/4 minus 1 3/4. Okay, we got a problem here now because you cannot subtract a 3 from a 2. We have to borrow from the whole number. So when we borrow from the whole number in the fraction world, we add the denominator to the numerator. So this becomes a 6. Instead of like in the whole number world, you just add a 1 right here. In the fraction world, you add the denominator to the numerator. All right. So now we're going to have 6 minus 3 is 3. The denominator stays the same. We don't have any more whole numbers because 1 minus 1 is 0. So 3/4 is our final answer. Took a while, but we got it. You might have to watch this one a couple times. All right. Moving on. Problem number 9. What is the solution to the equation 6 times x equals 27? So what's the opposite of multiplication? Division. So to solve this, we have to do division, and we're going to divide both sides by 6. This is what I use for division in equations. I use the fraction bar. 6 divided by 6, 27 divided by 6. Okay? Alright, 6 divided by 6 cancels out. It's just 1. And then 27 divided by 6 is not going to be a whole number. It's going to be a fraction. And since you can see it's in decimal form over here, you can use your calculator. What is 27 divided by 6? You'll get 4.5. Okay? Moving on, problem number 10. For which equation would x equal 9 not? You got to pay attention to these nots because kids will answer, get confused by that. That changes it. So this 9 can be a solution to 3 of these. 7 times 9 is 63. 5 times 9 is 45. 10 times 9 is 90. Wait, this is 80. So this is the one that it's not a solution for. 9 times 9 is 81. So this is the one that is not. Okay, make sure you pay attention to the not. And then break the code. See which one of these is not. Problem number 11. What is the solution to this equation? Well, this means division. So to solve this, we have to multiply. We have to multiply this by 8, and we have to multiply this by 8. Okay? These 8s will cross cancel out, leaving you with just x. We isolated the variable. And then we have to go, no, what is 16 times 8? 128. So 128 divided by 8 equals 16. Okay, problem number 12. What number should both sides of the following equation be multiplied by to solve for x? Okay, see this equation is saying x divided by 5.43 equals 12. So to solve, we must do the opposite of divide. We must multiply. And we're going to multiply by the number closest to the variable, the 5.43. Problem number 13, translate the following into an inequality. What number, okay, so what number would be a variable, which it looks like they're using the letter M for their variable here, divided by 5, and they're also using the division sign this time, not that fraction bar sign, is less than. Okay, is less than is different than just is. Is, you would use an equal sign. Is less than, you would use this arrow right here. 8. So M divided by 5 is less than 8 right here. All right, problem number 14. For which inequality, they use the word inequality whenever you have these little arrows in the equation instead of equal signs. Okay, so every time you say the word inequality, it's because they're using these arrows. For which inequality would x equals 5.8 not, remember the not, be a solution? So what you have to do is take each inequality, substitute 5.8 where the variable is and work it out. And I wrote it out already where I did not. Okay, fix that. Can you see that? It's getting a little closer. There we go. Okay, so 5 times, let's work the first one. 5 times 5.8 is 29. You can use your calculator. 29, okay, so then we have to put 29 minus 14 is greater than 3. Well, what is 29 minus 14? It's 15. 15 is greater than 3. Okay, so is 15 greater than 3? Yes. So we have a positive outcome, and we are looking for a negative one because they're looking for a not. We're looking for where this answer is going to say, no, that's not true. Okay. All right. 5.8 minus 9 is less than 0. Okay, so let's see. What is 5.8 minus, and we get negative 3.2 is less than 0. Is negative 3.2 less than 0? Yes, it is. This is also a positive outcome because we can answer yes. So let's move on to the next one. 5.8 plus 6 is less than or equal to 10. Let's see. What's 5.8 plus 6? Should be 11.8, right? And then we have to put the less than 0. 10. Is this true? Is 11.8 less than 10? No. Okay, so we found the one that is not a solution. This one right here. So you have to take the number that they give you for the variable, substitute it in each equation, and solve to see which one answers this question. Problem number 15. The graph of an inequality, that's when it has these arrows, has an open circle at 7.5 and the ray moves to the left. What inequality is graphed here? Okay, let's talk about open circles and closed circles. When you use these inequality symbols with the underlines, then your circle will be closed on a number line. Like, let's put a... This would identify your inequality symbols that look like this. If your inequality symbols are just the arrows, the greater than less than arrows, with no underlines, you will have what's called an open circle, like this right here. Okay? So since this says an open circle, we know we are going to use these inequality symbols here, not these, these. So it's either going to be this one here or this one here. Not either one of these. Okay. The ray moves to the left. So we need to choose the circle, the inequality that shows the symbol pointing to the left, because that's the direction it's going to go, to the negative direction. So x is less than 7.5. This arrow is pointing to the left. It would be this one right here. Not this one. This one's pointing to the right. We want the one pointing to the left. All right, problem number 16. What inequality is graphed below? Oh, hold on. Okay, I had to erase that circle I put there. Point. Okay, so remember, open circle. We have an open circle. That means we're going to use these symbols here with no underlines. And the arrow is pointing to the right, so we're going to want an arrow that points to the right. So looking at these, we're going to cross out all the underlines because we know it's not closed circle. And then we're going to choose the one where the arrow is pointing to the right this time. Problem number 17. What is the output value for the following function if the input value is 5? So the input value has to go go in place of the variable. We have to break the code again. We're going to put a 5 instead of an x. Okay, 6 times 5 instead of 6 times x. 6 times 5 is 30. 30 plus 2 is 32. So that's easy. 32 is the answer. Problem number 18. What is the input value for the following function if the output value is 5.5? Okay, the input value stands for the variable x, and the output value stands for the variable y. So when you see a y and they gave you y, you need to rewrite the problem putting the number instead of the letter, or the constant instead of the variable, and then solve like that. Okay, so to solve for this, remember what we have to do to both sides. The opposite operation that is being done to the variable is being added to 2.8, so we're going to subtract 2.8, and we're going to do it to both sides. All right, this cancels out, so all we have left is x, and then 5.5 minus 2.7. All right, problem number 19. Which row of the input-output table is incorrect? So what I did was, they gave you this, I believe it's called a key, and I wrote it out next to each row using the numbers they gave for the input. The input here was 4, so I used 4 in place of the input. The input here was 6, so I used 6 in place of the input. 7 and 10. Okay, and when you do the problem, it has to equal the output, which here are all the outputs, the y values. So I just put equals, like this is y equals 3x plus 2. These are all the y's, so 14 equals 3 times the input plus 2, 3 times the input, and so on. Okay, so here we can see 3 times 4 is 12. 12 plus 2 is 14. Yes. 3 times 6 is 18. 18 plus 2 is 20. Yes. 3 times 7 is 21. 21 plus 2 is 23. No. We have 26. 3 times 10 is 30. 30 plus 2 is 32. Yes. Okay, so row C is incorrect. All right, problem number 20. What function is graphed below? Okay. In order to figure it out, you have to know the numbers that go with each point. So I went ahead and I wrote out the numbers that go with each point. This point is 4, 0. It's on the 4, 0 line. This number is on the 6, 1 line. This number is on the 8, 2 line. Do you see that? 10, 3, 12, 4. All right. Then what I like to do is make a T-chart with all the X values or inputs on the left and all the Y values on the right. Remember, these are called the inputs and these are called the outputs. All right, so whenever you put in a 4, you should come out with a 0. Whenever you put in a 6, you should come out with a 1, and so on. So let's start with the first one. Take the input 4, divide it by 2, and so it would look like this. Y equals 4 divided by 2 minus 2. Y equals 2 minus 2. Y equals 0. Well, the first one worked for this equation. So let's move on to the second one. You have to have at least 2 or 3 that give you a positive outcome. So let's start with, try 6. So y equals 6 divided by 2 minus 2. Y equals 3. Well, because if you cross these out, you get 3 minus 2. Y equals 1. So far, so good. This one is looking like our answer. Let's try one more. As long as we have 3, we can be pretty positive. So let's go with y equals, draw a line here to separate these. 8 divided by 2 minus 2. Y equals 4, because when you cross cancel, it's 4. 4 minus 2, y equals 2. Okay, we found it, because for 3 of the input outputs on the t-chart, we got positive answers, or a yes for each one. Y 0, 1, and 2. So this is the correct answer right here. You can see quickly that this one is not the right answer, because 4 times 4 is not 0, it's 16. We can see this one's a little tricky because the first one works. 4 minus 4 is 0, but on the second one, 6 minus 4 would be 2, and they have instead of a 1. All right, that's the end of the helps for this study guide. And I hope you do good on the test.